Most researchers run an experiment, go to sleep, and wake up to find it crashed at hour 3. 8 hours of GPU time, gone. This project changes that. It is called Auto Deep Researcher 24x7, and it is an autonomous agent that designs, runs, monitors, and iterates on deep learning experiments while you are completely offline. Not just scheduling jobs. Actually thinking about what to try next. Here is the core loop. You give the agent a research goal in plain text. Something like, improve image classification accuracy on Safari 10 with limited compute. The agent breaks that down into concrete experiments. It picks a model architecture, sets the hyperparameters, launches the training run, reads the results, and then, and this is the part that matters, it decides what to change and runs the next experiment automatically. No human in the loop. No approval step. It just keeps going. What makes this technically interesting is the memory design. Most autonomous agents accumulate context until they hit a token limit and either crash or start forgetting early information. This system uses constant size memory. No matter how many experiments run overnight, the agent's working memory stays the same size. It compresses and prioritizes what matters, so experiment 50 is informed by everything that happened in experiments 1 through 49, without blowing up the context window. The monitoring layer is zero cost by design. It does not rely on expensive observability platforms or paid API dashboards. Everything runs locally. You get a structured log of every decision the agent made, why it made it, and what result it produced. When you wake up, you are not reading a crash report. You are reading a research journal. But here is the thing, let's be precise about what this actually handles right now. The system is built around a specific class of deep learning tasks. Supervised learning, classification, regression, the standard workbench. It is not a general-purpose research agent that can pivot from computer vision to natural language processing mid-session. If your experiment requires a custom training loop that deviates significantly from PyTorch or standard Keras patterns, you will need to adapt the scaffolding yourself. The agent is smart about hyperparameter search and architecture choices within a defined space. It is not inventing new loss functions. What surprised me was the GitHub setup time. If you have a working Python environment with the right dependencies, you are looking at maybe 20 minutes from clone to first autonomous run. The configuration is a single YAML file. You define the task, the search space for hyperparameters, the compute budget, and the agent handles the rest. There is no cloud account required. No API key for a hosted AI service. The whole thing runs on your local machine or whatever server you already have. Now, what it does not do. It does not handle multi-GPU distributed training natively. If you are running large-scale experiments that need to span multiple machines, you are outside the current scope. It also does not produce publication-ready reports. The logs are structured and readable, but turning them into a paper is still your job. And the agent does not verify the validity of your dataset. Garbage in, garbage out, it will faithfully optimize toward a bad objective if you set one up. The token-efficient memory is also not magic. In very long sessions with highly varied experiments, there is information loss. The compression heuristics work well for iterative refinement within a similar task family, but if the problem space shifts dramatically across a session, early context can get squeezed out in ways that affect later decisions. The developers are transparent about this in the documentation, which is a good sign. So where does this realistically go? The most credible near-term use case is small research teams and solo researchers who have GPU access but not enough human hours to babysit overnight runs. Imagine setting this up on a DigitalOcean GPU droplet, defining your experiment space before dinner, and reviewing a ranked list of results with the agent's reasoning attached when you sit down with your coffee the next morning. That is genuinely useful today. Longer term, if the constant size memory approach gets refined, you could see this kind of agent running week-long research campaigns. Not just tuning hyperparameters but exploring fundamentally different approaches to the same problem and keeping coherent notes across the entire campaign. That would close the gap between what a well-organized human researcher can track across a week and what an automated system can explore. There is also an interesting angle for educational use. Students running ML coursework could use this to understand not just what result an experiment produced but why the agent made each decision. The structured logs become a teaching artifact. Why does this project exist? Because the bottleneck in most deep learning research is not compute. It is iteration speed. GPUs sit idle at 3 a.m. not because there is nothing to run, but because no one is awake to read the results and queue the next job. The researcher becomes the rate-limiting step. This project tries to remove that bottleneck without requiring a paid service, a cloud account, or a team of engineers to maintain the infrastructure. That is the honest case for it. It will not replace a senior researcher's intuition. It will not write your paper. But if your GPU has been sleeping while you do, this is worth a serious look. Next episode, we are looking at a tool that automatically reviews your own ML code for training bugs before you ever run a single epoch. If you have ever spent a week training a model only to find a pre-processing error that invalidated everything, you will want to see that one.